Studies Section 6 Descriptive Statistics 2 Introduction. This lecture is the concluding part of our discussion on descriptive statistics that we started in the last lecture. We shall examine the degree to which a set of figures deviate or spread about their average. The mean deviation, the range, and the variance are some of the measures of dispersion that will be discussed in this lecture. Objectives. At the end of this lecture, you should be able to 1. Define and calculate the mean deviation. 2. Define and calculate the range. 3. Define and calculate the variance. 4. Deduce the standard deviation from the variance. 5. Interpret the values of each of the above measures. Pretext. Attempt the following questions before you proceed to study the lecture. 1. The difference between the highest and the lowest score in a distribution is called A. Mean deviation, B. Range, C. Standard deviation, D. None of the above. 2. When a group of scores have a large variance, then the scores are said to be A. Far apart from their median, B. Far apart from their mode, C. Far apart from their mean, D. All of the above. 3. The measure that evaluates the proportionality between a mean and a standard deviation is the A. Coefficient of mode, B. Coefficient of variation, C. Coefficient of proportionality, D. Coefficient of standard deviation. 4. The value of the coefficient of variation always lies between A. 0 and 1, B. -1 and +1, C. -1 and 0, D. All of the above. Content. Section 1. Measure of dispersion. If we have a set of values like the data on Nigerians' defense expenditure, table 5.1, some of the values will be close to group's average while others will be far away from group's average in terms of magnitude. The degree to which these values tend to spread about or deviate from the mean value is what we call variation, variability, or dispersion. In this section, we shall examine the following measures of dispersion: the range, the mean deviation, the variance, and the standard deviation. 1. The range. The range is simply the difference between the highest score and the lowest score in a distribution. When all scores in the distribution have the same value, the range is 0, that is, no variability. The higher the value of the range, the further apart are the extreme scores of the distribution. A weakness of the range is that it considers only the two extreme cases in its computation. Example: find the range of the following income distribution in a private establishment: 50,000 naira, 20,000 naira, 150,000 naira, 32,000 naira, and 5,000 naira. Solution: income range is equal to highest minus lowest income is equal to 150,000 naira minus 5,000 naira is equal to 145,000 naira. This shows that there is a high degree of income inequality in the establishment. 2. The mean deviation. The mean deviation is simply the average distance from the mean of all the cases in a distribution. NB. Now that you are becoming familiar with some of the symbols in this course, we shall introduce some new formulas which are quite similar to those encountered in the previous. Before then, let me remind you that symbol X stands for numerical value of a variable, symbol X bar stands for mean or average value of a variable X, N stands for the total number of cases in the distribution. Sigma implies summing up. For an ungrouped data, mean deviation MD is equal to sigma absolute value x minus x bar over n. For computation purposes, use the format below to arrange your work. X bar, absolute value of x minus x bar. 1. Put the values of the variables. 2. Insert the mean, which is a constant. 3. Subtract the mean from each value, ignoring negative signs. The two vertical lines in column 3 means absolute value, that is, ignore negative signs. For a group data, use mean deviation MD is equal to summation F absolute value x minus x bar over n, and the computation table should be arranged as follows. Class mark x, frequency x bar, absolute value of x minus x bar, and frequency times absolute value of x minus x bar. The symbols are as explained above in the ungrouped case. Note that the MD retains the original unit used in measuring the data. We shall take an example to illustrate this concept soon. Before then, let us discuss the variance and standard deviation. 3. The variance. The variance is also an index that reflects the degree of variability or the average distance from the mean of all cases in an interval level distribution. However, it relies on the square distance between x and x. Its derivative, the standard deviation, converts the squared unit to a linear one. The variance is computed by variance square of standard deviation in bracket is equal to summation x minus x bar squared over n for ungrouped data. Variance is equal to summation f into bracket x minus x bar squared over n for a grouped data. 4. The standard deviation. The standard deviation, which is the derivative of the variance, is the square root of the variance. That is, standard deviation is equal to square root of variance is equal to square root of summation x minus s bar squared over n for ungrouped data is also equal to summation f into bracket s minus s bar squared square root over n for grouped data. Like the mean deviation, the standard deviation is relatively large if the cases are widely dispersed about mean. If all the cases take on the same value, the standard deviation is 0. 5. Coefficient of variation, CV, is equal to standard deviation over mean. It evaluates the proportionality between a mean and a standard deviation. If CV is equal to 0, there is no variation. If CV is equal to 1, there is a good deal of variation. Illustration. 1. For our defense expenditure data 5, 8, 10, 9, 11. Calculate the 1. Mean deviation, 2. Standard deviation, 3. The variance, 4. Coefficient of variation. 2. Go back to example 5.3 and compute the following. 1. Mean deviation, 2. Standard deviation, 3. The variance, 4. Coefficient of variation. Solution. 1. Since this is an ungrouped data, for 1. Mean deviation, use equation 6.1. Thus, MD is equal to summation of absolute value x minus x bar over n, but x bar is equal to 5 plus 8 plus 10 plus 9 plus 11 over 5 is equal to 43 over 5 is equal to 8.6. Therefore, mean deviation is equal to 5 minus 8.6 in bracket plus 8 minus 8.6 in bracket plus 10 minus 8.6 in bracket plus 9 minus 8.6 in bracket plus 11 minus 8.6 in bracket over 5 is equal to 3.6 plus 0.6 plus 1.4 plus 0.4 plus 2.4 over 5 is equal to 8.4 over 5 is equal to 1.68, that is 1.68 billion US dollars. 2. To get the variance, we use equation 6.3. Square of standard deviation is equal to summation x minus x bar into bracket squared over n is equal to 5 minus 8.6 into bracket squared plus 8 minus 8.6 into bracket squared plus 10 minus 8.6 into bracket squared plus 9 minus 8.6 into bracket squared plus 11 minus 8.6 into bracket squared over 5 is equal to 3.6 squared plus 0.6 squared plus 1.96 squared plus 0.16 squared plus 5.76 squared over 5 is equal to 12.96 plus 0.36 plus 1.96 plus 0.16 plus 5.76 over 5 is equal to 21.2 over 5 is equal to 4.24. That is 4.24 billion US dollar. 3. Standard deviation is equal to square root of variance, which is equal to square root of 4.24 is equal to 2.059 is equal to 2.06 billion US dollar. 4. Coefficient of variation CV is equal to standard deviation over mean is equal to 2.06 over 8.6 is equal to 0.239 is equal to 0.24. The social information here is that since the coefficient variation is very small in magnitude, we may conclude that there exists only a little variation in the defense expenditure within the 5 years. The values are indeed close to the average. Solution to example 2. We expect the student to provide a solution to this problem and submit it to the tutor for grading and necessary corrections. Summary. The measures of central tendency give a value around which other values within the distribution clusters. The mean is the typical value that considers all values in the distribution for its computation. The mode is the score that occurs most frequently, while the median divides the distribution into 2 equal halves. The measures of dispersion depict the degree to which the figures tend to spread about their average. The smaller the coefficient of variation, the lower the degree of variability. This is the end of study section 6. Thanks for listening.